Hi, I'm Justin, and I'm going to talk about some communications examples that are possible with the Decelium software stack. So, again, the general realization with Decelium is that users bring their own computers to your application. So, whether someone's showing up with a phone or a laptop, the key insight or the key bias of our technology stack is that any individual can actually take on some of the server side processing for you. So that can include processing payments, that can include running multiplayer sessions, that can include operating chat servers, that can include, GPS device checks, that can include anything most of the work that you do on the back end could happen on the front end. And that allows for services to scale to much larger workloads and take on much less data risk. Um, it's covered elsewhere, but the Decelium software is broken into three layers: a decentralized cloud layer, a transfer layer, and a proof layer. I'll leave other videos and other assets to discuss, this picture in detail, but I won't do that here. Here's some examples of the software as it relates to communication products. So I'm not going to go through this in detail, other than to say this slide might be useful for reference. But in general, on Decelium, other users' computers, as they run your product, add more network capability because each user is a server. If you're hosting on something like AWS or Google Cloud, as you add more users, you add more expense and more security pressure. So this key insight alone um, usually gets people thinking, oh, I never thought about that. If every user was a server, then it means as my platform becomes more popular, I have more servers, and you do. A second key insight is that if other users are bringing the server stack with them, if they're helping you run your app, each new mobile user signing up is running a piece of your services, then if they're also handling private data themselves, then private data becomes the end user or the network responsibility. It's no longer corporate responsibility. And so, depending on your industry and the nature of the data you're managing, I like healthcare records as an example because we did a really great healthcare project. Um, you know that data ends up being the person who owns the healthcare records responsibility, and then the corporation can save sometimes millions of dollars in jurisdictional fees and like legislative processes, certifications, things like that. Can sometimes you can skip. I've seen people skip 90% of that stuff. So this is really great. So let's talk about user management because this is a good example. Um, if you have a user coming to your platform, assuming they're on a laptop, they might want to access a website and do something like register a user, recover a user, or if they're a malicious user, they might want to guess some passwords. So if you're on a traditional setup, you might have something like an AWS or a Google Cloud team. You might have a business team logging in on some sort of ticket software, and you might have some IT staff, and you're going to have a database with user registrations. All of this is both an audit and a security problem to deal with. And depending on your relationship with your users and how rigorous your sign up process is, this could also just be an IT nightmare or something that's rather simple. It just depends on your application. Regardless, this is a problem to be managed. Um, we have a well managed self user registration system that kind of comes out of the transfer layer, where individuals can register their own users on their own device and then spread their proof of that user account around the network. And that means the IT staff and business staff can see and query the network of users to see what the users are. And you could certainly do all sorts of analytics on that data set, but you're not in custody of that data legally. So you don't have to worry about uptime. You don't have to worry about all sorts of issues with maintaining that kind of data set. Not to mention that it's, from a hacking perspective, it's pretty much impossible to attack a network like this because all these records are encrypted. You need to like somehow grab people's private keys, and without those private keys, then the data is encrypted and unrecoverable. So this is a good secure solution as well. Let's talk about secure messages. So the general way to do secure messages is very similar to user registration. Is you want to send messages, list messages, and process replies. So it's similar to user registration. Actually, it's almost the same solution approach, which is you just insert a record in a database saying, hey, this message was sent this date, and you make sure that you notify another user's phone, and both users, I didn't show the second user, but both users log into the same endpoint, the same domain, go to the same messaging server to download their latest messages. So this is a pretty classic approach. What some companies like Signal do is they just delete the messages on delivery, so they don't actually retain any. The Decelium network takes this sort of approach one level further, because we ask, well, what if we didn't get the message in the first place? What if the users operated their own messaging network? We, as the IT staff, have the ability to audit and update that application to pull down logs. And if we have the appropriate keys, maybe there's certain classes of messages that can be decrypted by the organization. Some can't, et cetera, et cetera. But the whole message broadcasting medium is peer-to-peer. It's an end-to-end encrypted, and it's run, the application is downloaded from the corporation, but the actual network is run by the users. And in this example, the destination user is given a special key directly from the user computer to decrypt the message, and this happens in under 150 milliseconds. It's quite fast. Device backups. This is a fun example because it's quite complicated. Backing up an image can be quite cumbersome and difficult. So it's a fun challenge, and it's not that hard on Decelium. So it's a fun example. So you imagine device backups, backing up all the media on your phone can be difficult. It's similar again to the user registration problem, except that these files are much bigger, and just because of the way people are, there's all sorts of passwords and notes and problems in this data set. So when LastPass was hacked, I think in 2023, they didn't anticipate that so many people would leave passwords in their notes field. And so it turns out when they got hacked, they weren't encrypting their notes field. Oh no, now their data breach cost users, a ton of identity theft, because they only anticipated that the password field had to be encrypted. And they left the note field and other fields unencrypted because they wanted internally for their IT and business staff the ability to search and manage LastPass data effectively. Well, unfortunately, a data breach happened, and all the users that backed up all their passwords essentially got doxxed. So that's a problem, obviously. So this backups problem is difficult. You have to somehow tag these images. You have to know who owns what image, and every single staff member. You imagine one of these people might be a high net worth individual. This is a very valuable data set for an illicit community. So it's very difficult to secure this. So if someone loses a device, generally what happens is that the corporation will send the image back to a new device, and you can restore your images. That's what Google's image service and the other image services in the world, like Dropbox, try to do this as well. That's what they do. Now, the way device backup works on Decelium is fundamentally different. Locally on the phone, the important directories are actually frozen and then carved into little encrypted buckets. You can't take a whole device or 10 or 20 or 30 gigabytes of data and keep it as one file. What you do is you get a backup key, and that backup key is your snapshot, or it's your write to your snapshot, right? And what you do is you take these cubes and you spread them redundantly across the network. And then you on the server side, like, you can't rely on this random person to always run the software and always keep the backup. They're good in a pinch, but what you actually do on the corporate side is gather up the fragments. But what this intermediate network has done is actually kind of mixed everything up with random IDs. So even if there was some sort of data audit over here, you could never tell what fragment corresponded with what device. But what's great is that the end user, the user who encrypted and backed up their data, has their little key, and with that key they can derive all the fragments that are back up, and they can even validate whether or not the backup is on an end server or is available on the network. And if they need to, they can recover those fragments from a mixture of the corporate services if desired, or just from the Decelium network, and restore their images and their notes and everything else on their device. So there are obviously many other applications that are possible other than these. Chats, events, image hosting, transferring contact cards, hosting of whole email Docker servers, registration processes, KYC, payment processing, and identity verification. All this stuff can be done on, you know, on users' computers, not on a custodial service, saving, saving organizations lots of time and complexity. So that's the general overview of the Decelium network from a communications perspective. If you're curious about more examples, there are many more example videos, and there's also a deep dive technical video about each of these layers and how they work. Thanks very much for watching. I'll talk to you later.